race condition. There is obviously a technical definition of race condition, but think it like this. Let's say you and your friend is trying to color on the same canvas in the same object or in the same part of that canvas. For example, the sun in the canvas. Let's say you are doing an art and you are trying to color the sun on in that art at the same time with two different colors. Let's say you want to color the sun with yellow and your friend want to color that in orange. Now if you both color the sun at the same time, then it will create a mess, and as a result the sun will have a color that will not either yellow and not either orange, not even close to a color of the sun. So this example describes a race condition that we usually face in computer science or in software development. So when two sources or two threads try to access the same data at the same time, and those two threads or two sources try to change that data at the same time, that is where race condition comes in. Now in my screen, see, we have this data, right? What we have other than that is thread 1 and thread 2. Now thread 1 and thread 2 will try to enter this section, this data section at the same time, and work with this data at the same time. Now you might ask me that what's the problem? That sounds at the first level, at the first glance, it sounds like efficient way that both are working at the same time, but that is a problem. Why? Let me demonstrate. See how this will work. In computers we cannot update any data. Yes, we can wrap it in functions like update function, but internally we have to first read the data, and then we can write the data. There are two requests that must go on. First is the read, and depending on the current value of the data, then we can write the new value in the data source. So in here what's happening is, let's say, think it like this. This is thread 1 and this is the timeline of thread 1, of the whole process of thread 1 processing, and this is thread 2 and this is the timeline of thread 2. Now what is happening here is thread 1 is first sending a request to the data source, and then it's getting back a response with the data value, and it is then generating the new value, like calculating, let's say, add 5 to the previous value, and then it's sending back a write request. It's doing a write request with the new value to the data source. And thread 2 is also doing the same thing, but think it now from the perspective of this data source. What it will say is, it first got a read request. It first got a read request. It obviously does not know which thread it get from. It does not keep track of that. What it says is, yeah, I got a read request from somewhere, so I sent the response back with the value. I got another read request. See, after this read request, the data source did not get the write request from thread 1. After the read request from thread 1, it got another read request from thread 2. See the sequence of this: first read request from thread 1, then another read request from thread 2. Notice the sequence of the requests. So what it got is a read request from thread 1. It responded back with the value. It got another request from thread 2. It responded back with the same value to thread 2. Then it got a write request from thread 1. Then obviously it again did the changes in the data source. Then again, after this write request, it got another write request from thread 2. It then again did the necessary changes in the data source. Now it might not seem yet seem like a problem to you, unless I can give you an example with numbers. Let's say, think of a banking system. Think of a banking system and think that one user that have only $700 in his account, and he issued two checks, one with $300 and one with $500. Now both of this can be executed at the same time, because obviously the banking system have its own server, and two checks can be issued or can be processed from two different sources at the same time. That's a edge case, that's a possible issue. So this 300 can come from thread 1, and this 500 request can come from thread 2, and our data have only $700. Now we can obviously process 300 individually, we can do 500 as well individually, and then this if we do 500 only, then the total amount will be deducted to 200. But we cannot do both cannot be cut out from their account, because they do not have sufficient balance. Now what will happen in this system is thread 1 will go with $300. They'll first do a write request. They'll first send a write request to the data source. That will obviously send back 700. Yeah, that it will say that yeah, this user have $700 in their account right now. What will happen next is thread 2 will send a read request to the data source. Then obviously the data source will again say that yeah, I have $700. Why? Because thread 1 did their write request. They have not completed their write request yet. So it will obviously again say that yeah, I have $700. This user have $700 in their account. After this step has completed, now thread 1 will go in will send the write request that yeah, this user have to deduct for the new value of the user in their account should be 400. Why? Because they have issued a $300 check and we have deducted the value. So it will send a write request with 400. Now the value will be updated to 400, right? Now this write request have processed, that's complete. Now when this write request will go in, it will say that the new value of that user should be 200. Why? This one calculated that yeah, I had 700 before, I deducted 500, now the user should have 200 only. Now this one will send a write request to 200, so this will be updated to 200, right? Now can you see the problem now? We successfully processed both of the requests, 300 and 500, and still our bank account have our source, or the bank account in the example have $200, right? We have 700 in the initial stage, we have completed a process of 300, we have completed a process of 500, now we have $200, which is obviously a bad math, which is obviously wrong. That's not good. Why did this happen? Because the data source sent same data, same response to the read requests to both of the threads, right? Now that's the problem of race condition. What's the possible solution to it? There are multiple solutions to a race condition. It highly depends on the structure of your app, or the situations, or your dependencies and structure of your app in general. However, I'll show 3 solutions in this video. Let's see one by one. The first one, solution 1. Well, I guess you have the first thing that catched your eyes, I suppose, is unsafe. I have written here in a bracket that unsafe. Now why it is unsafe, don't worry about it now. Let me first describe it, that what's the solution I'm coming up with, then we'll discuss why it's unsafe or not. See, what we will do here, what this process will do is thread 2 will wait until thread 1 have completed their whole task. And by whole task, what I mean is the whole process of updating from reading to writing. thread 2 will wait by itself. We are not forcing thread 2 to wait. Thread 2 is waiting by their own self, by its own self, that I will wait until thread 1 completes its updating process. I'll wait until that. Now that's the simplest solution. Yep. Now tell me if this solution is safe or not. I'll say unsafe. Why? We are giving permission, or we are giving control to the user or to the consumer to wait until one consumer completes its task. We are giving that control to the consumer of our product. Why it's unsafe? Obviously the consumer, it's up to the consumer if they choose to wait or not. If they do not choose, what will happen? Our system will break, and it is very much unsafe. Yeah, is it solving the problem? Yes, it does. Yes, it is. It is indeed solving the problem. But is it safe? No, it's not. Why? Because we are giving control to we are relying on the consumer. That would be a good word for this. Now, here goes the solution 1. What is the solution 2? Let's check on that. Now, here's solution 2. And again, I believe I'm assuming the first word that's catching your eyes is bad. Well, should I name it bad? No. But why did I name it bad? We'll see later. It's actually because the example that I built to show you, it's bad for that scenario, but it's not bad for all the things. First, let me tell you what's the solution here. So the solution is not so much difficult. It's really simple. That, see, I first received a read request from thread 1, and then we will create the structure like this, that if a updating process is going on, see, the whole thing, this read and write, both read and write is the whole updating process. So what will make this structure like is, if any of the updating process is going on, I will not accept any request until a updating process completes from any of the thread. So when we sent a read request from thread 1, our data source will go in a rejection mode or a blocking mode. That, yeah, I am blocked now because someone is working with my data. And when the read request from thread 2 comes in, it will just reject it. It will send a rejection response. So our data source is safe. It does not create a false value. It does not create a false value. It's safe, and it will be unblocked when the when the write request is complete. It will be unblocked then. Now, why I'm saying it's bad? The problem here is thread 2 have to send the request again and again by themselves until it succeeds. Why? Because thread 2 does not know when the whole process, or a whole updating process of thread 1 will get completed, right? That's why it's a bad solution, because it is giving a bad user experience. I'm treating thread 2 as a different user. Well, then thread 2 have to send the request again and again. Now, when it is not bad, it's not bad in cases of UI. At least I have seen it like this. This solution is so much commonly used when it's about UI. Let's say you have a sign-in form, and you have filled the form and click the sign up button. Now, you as a developer obviously do not want your user to click the sign up button again while the sign up process is happening in the backend. You obviously do not want that. Then to solve it, what you do is you block the whole system of calling the sign up function, right? You just if one process is happening, you just reject the other calls or other requests. You just reject that. Or if we see it so much commonly that when the sign up process is working, the button is disabled. The button gets disabled when the process is working. So this is the solution so much commonly used in when it is about UI. Now what's the third solution? Let's see on that. Now first you will see that I have covered the middle area of this diagram. Why I did that, I'll tell you shortly. But first, focus on these two parts. Focus on these two parts. It is in the first glance, it seems that it's so much similar to the first initial stage that we had in the problem stage. It's sending the thread 1 is sending a read request, then thread 2 is sending a read request, then thread 1 is sending a write request, then thread 2 is sending a write request. They're not worrying about if the data source is occupied or not, is blocked or not. They're not worrying about that. These two threads, and all the requests are getting accepted. All the requests are getting accepted, right? Now what's the solution here? Actual solution here? The solution here is queue. What is a queue? Queue means whenever I get a request, I'll not, if I am blocked, if I'm occupied and working with another request from another thread, if I get a request from another thread, what I will do, if I get a request from other thread for the same resource or same data source, what I will do, I'll not reject that request. I will just keep it in the queue, keep it in the waiting line. Think it like this. When you go in a shop, the cashier, let's say the cashier is busy with another customer, and you also have to work with that cashier, deal with that cashier. Now, does the cashier tell you to go in your home and come back later, come another day? Does she tell you like that? No, she does not. He or she. What she tells you is, sir, she simply tells you to wait in the line, right? She tells you that I am busy with this customer right now. You just wait in the line, and when your turn comes in, I will deal with you. I'll solve your problem. And that's the same approach that we are trying to implement here. What we are doing is, first, the read request from thread 1, our queue section where we're implementing, we have implemented another or added another layer surrounded to the data source named as queue section, and it will handle all the queuing and stuff. So first, what we are receiving is a read request from thread 1, and on behalf of thread 1, what queue section is doing is sending the read request on behalf of thread 1. It's sending it to the data source, right? What's happening after that? The queue section is receiving another read request from thread 2. Now, is it rejecting this request? No. What it's doing? It's simply first it's keeping the read request in a queue. And when it will get executed? Only after the data source is free. Why? Because the data source is occupied now, and it is working with thread 1, right? It will be freed up when thread 1 sends the write request, and it processes that write request. Only then it will be free. So what the queue section is doing? It first sending the read request from thread 2 to the queue, and only when the data source is free, it's sending back on behalf of thread 2, it's sending back the write request to the data source. And same goes for the write request from thread 2. Now what's the benefit of this solution? That both or all the requests that we are getting to access our resources, none of them are getting rejected. We are accepting all of them, and our data source is also not producing any false data. That's the whole idea of the solution. Now, is this three are the only solution to race conditions? No, it's not. It highly depends, as I mentioned before, it highly depends on how you are structuring your app or your code, and what's the situation of your race condition. It highly depends on that. Okay, as the video is getting too much long now, so let's call it a night today, and we will see the code part of this problem and these three solutions in the next part of the video. Okay.